Hello there, and you are welcome. I am Uncle Baje. Today is lesson 4 of the topic skill drawing. We have introduced skill drawing, we have talked about the skill factor, we have also looked at how to use that skill factor to calculate the model sizes when we know the real sizes. Now, imagine that you're a structural engineer and now you have a plan on paper. But it is one thing to have a plan on paper, it's another thing to be able to translate that plan to an edifice that will wow people. And this is where skill factor comes in. This is where skill drawing becomes important, because one wrong measurement, buildings could collapse, accidents can happen. So, how do you get it right? You get it right by learning how to calculate your skill drawing as well. So today we're going to be looking at how to calculate real distances, how to translate plans to actions. So to do this is actually very easy. The formula that we are going to be using is that according to the plan, actual size is the same thing as skilled size divided by skill factor. But then in this case, the skill factor has to be written as 1 over something. However, I will leave you to go through the content of the note and see how this method has been used. In this video, I'm going to be using the common sense approach just like we used in the last example. Let's look at example 1. Imagine you have a scale drawing of a building. Imagine that you have a scale drawing of a building where the height is represented as 6 meters on the plan. That is what's on paper. And the scale factor is 1 to 8. And you have been tasked with bringing this drawing on paper to life. How do you calculate the actual height of the building? Well, it's very easy. Let's go to a page and write out what we know. What we know is the model height. Model height is 6 meters. We also know the scale factor is 1 to 8. Now we'll pick the important number there. That tells us that one height is 8 times of the other one. Since we know the paper height, the real height, will it be greater or less? Well, the real height of the paper would not be able to contain the paper. It has to be greater. And since it is greater, then that means that the model height has to increase. By what? By the scale factor. And we have the scale factor here as 8. So since we know the model height and we want to increase it to the real height, on a factor of 8, we just multiply by 8. To multiply is to increase. To divide is to decrease. The one we want to calculate has to be greater, so we have to multiply. So in this case, we say the actual height is the model height times the scale factor. But in this case, we are picking the most important number in the scale factor, and that is just 8. It's either you go with this approach or you go with the approach on the plan where you have to stick with one so you do not get confused. I love this approach. 6 meters times 8 is 48 meters. So that means that if the model height on paper is 6 meters and the real height is supposed to be 8 times larger, then the real height has to be 6 times 8, and that is 48 meters. Let's check if we're correct, and I'm very sure that we are. Yes, of course, we are. But let's look at example 2. This says, consider a scale diagram. Whenever you hear a scale diagram, that means the paper, the plan, the model. The width is depicted as 40 centimeters and the scale factor is 1 to 60. Now, what does that mean? The scale factor of 1 to 60 means one size is 60 times bigger than the other one. So, how would you determine the actual width of the garden? Let's go and see what we can do with that on our work page. I have it right here. So, we'll look at the paper distance or the model size, and that has been given as 40 centimeters. Then we're given a scale factor of 1 to 60, which means that one size is 60 times greater than the other. And now if the paper one is 40 centimeters, the real one has to be greater than that. So that means we're going to be multiplying by the scale factor. And so that is 40 centimeters times 60 centimeters. I just do 4 times 6 and you get 24. And I add the 2 zeros. So that's 2,400 centimeters or 24 meters, as the case is when you convert centimeters to meters. So let's check if we're correct, and I'm sure that we are. Yes, of course we are. 2,400 centimeters or 24 meters. Now I'm going to go from there straight to the classwork, so see what we can make of the exercise. I'll just do one. I trust that you have the rest on the wraps. Here it says the actual height of a building. We're to calculate it based on the scale drawing. The scaled height is 12 meters. So we know the model height. When you talk about scaled height, that's the model height. That's 12 meters. And the scale factor is 1 to 6. And what that means is that 1 is 6 times greater, 6 times of the other one. So the real has to be 6 times greater than the model that we know. So the real has to be greater. And since it is going to be greater, we're going to multiply or divide. We are going to multiply. So we're going to say, since the model is 12 meters, then the real has to be 12 meters times in 6 places. And that is going to be 72 meters. And that is what your answer should be. You will be able to take care of the third example and the second exercise. Let's see if we're correct. And I'm pretty sure that we are. Yes, the answer is 72 meters. So I trust that you can figure the rest out by yourself. We have looked at scale factors this week. We have looked at introduction to scale drawing, what scale factors are, when we know the scale factors, how to calculate the model size, how to take a real plan and put it on paper. And now today we have looked at how to take what's on paper and put it in there as a real thing. In the next lesson, we're going to be looking at applications in real life, and that is where scale drawing becomes very, very interesting. Till then, see you then. Bye bye now.